Pluck a string, just one. It quivers, so fast your eye cannot follow. And in that moment, something invisible is born and rushes outward into the room, unseen, unstoppable. Racing towards you at roughly 340 meters every second. You cannot see it. You cannot touch it. Yet when it reaches you, something extraordinary happens. You feel, welcome, explorers, to the strangest fact in all of music. Music is not made of sound. Music is made of movement. Let us look closer. When that string trembles, it shoves the air molecules beside it. Those molecules crash into their neighbors, who crash into their neighbors. And outward the disturbance travels, a rolling wave of squeezing and stretching air. Scientists call these compressions and rarefactions. Imagine dropping a stone into a still pond, ripples spread. Now imagine that pond is invisible, filling every corner of the room, and the ripples are racing in every direction at once. That is what a musical note truly is. An invisible ocean, rippling. And this reveals a haunting truth. Sound cannot travel without something to ripple. In the vacuum of space, a violin would tremble in perfect, eternal silence. Music needs air. Music needs a world. Now, let us ask the first great question. Why are some notes high and others low? The answer is beautifully simple. It is all about how fast the trembling happens. Scientists measure this in hertz, the number of vibrations each second. A string quivering slowly produces a deep, rumbling note. A string quivering furiously produces a bright, piercing one. The note musicians call A above middle C vibrates 440 times every second. 440! Faster than you could ever count, and your ear catches every single tremble. But your ear has limits. A young human can typically hear from about 20 hertz. A rumble so low it feels more like thunder in the chest, up to nearly 20,000 hertz. A shimmer so high it seems to hover at the edge of existence. Beyond those gates lies a hidden world. Dogs hear far above us, bats hunt in ultrasonic screams we will never know. Elephants speak to one another in rumbles too low for human ears. Conversations rolling for kilometers across the savannah. Secret messages passing right through us unheard. The world is far noisier than you know. Now for the true enchantment. Take a string, pluck it, then take a second string exactly half as long, and pluck that it vibrates exactly twice as fast. And something magical occurs. The two notes sound like the same note, only higher. Musicians call this the octave. And here lies one of the oldest wonders in science. A mathematical relationship, a simple ratio of 2 to 1. That our brains hear as sameness double the vibrations, and the note somehow returns home. Number becomes feeling. Push further, and the marvels multiply. A ratio of 3 to 2 gives what musicians call a perfect fifth. Two notes that lock together with a bright ringing stability. A ratio of 4 to 3 gives the fourth. Long ago in ancient Greece, followers Pythagoras noticed these ratios and were astonished. Why should numbers this simple sound this beautiful? Scientists today are still exploring the answer, studying how vibrations overlap, how the ear responds, and how the cultures we grow up in shape what we find pleasing. For that is the honest truth, young explorers. The mystery is not solved. Music remains a place where mathematics and mystery still hold hands. But there is one more secret, and it may be the deepest of all. When a string sounds, it does not vibrate in only one way. It trembles along its whole length, and also in halves and in thirds and in quarters, all at the very same time. Every single note you have ever heard is secretly a choir. Scientists call these hidden extra notes the harmonic series. Quiet ghost tones humming above the main pitch, layered inside it, too faint to notice yet impossible to remove. And this at last explains a riddle you have wondered about your whole life. Why does a violin sound different from a flute, even when both play exactly the same note? Because their hidden choirs are different. Each instrument sings its ghost notes in its own private mixture. Some loud, some soft, some missing entirely. That fingerprint of overtones is what scientists call timbre. It is the voice of an instrument, its soul written in physics. So the next time a single note rings out, listen harder. That is no simple sound. That is an invisible ocean, rippling toward you at the speed of a racing wind, carrying a hidden choir of ghosts, built from numbers older than civilization. And it has not even reached your ear yet. Next, the astonishing machine inside your head, and how vibration becomes feeling. The music travels on.